Every time you ask AI a question, every generated image, every line of code it writes, it's not just consuming electricity, it's consuming water. And the unseen cost, hidden from your screen, is far greater than you imagine. Your digital convenience is creating a physical thirst. A thirst so immense, it's drying up rivers and draining communities, all for machines you'll never see. For most of us, AI is pure magic. It's the seamless voice assistant that writes your emails, the artist generating breathtaking images from a few words, the intelligent search engine that answers your most complex questions in an instant. This is generative AI, learning from massive datasets, then creating something entirely new. It's integrated into our lives, into services like Google Search, used by billions every day, making our digital world feel more intuitive, more powerful, more human. It feels effortless, infinite, a technological marvel. But behind this boundless digital frontier, there's a very physical, very finite reality. This magic, this instant generation, isn't conjured from thin air. It lives somewhere. It lives in colossal data centers, sprawling industrial complexes that house millions of powerful computer chips. These aren't just server rooms. They are the physical brains of our digital world. Each building, often larger than an aircraft carrier, is a factory dedicated to computation. They consume vast amounts of electricity, enough to power small cities. But electricity isn't their only voracious appetite. They demand something far more fundamental, something that touches every living thing on Earth: water. The core problem is heat. Generative AI models are incredibly complex. Training them, running them, even just answering your search query, requires staggering computational power. Millions of processors work in unison, pushing electrons at blistering speeds. And every electron pushed, every calculation made, generates heat. Think of it like this. Imagine an entire city's worth of tiny, super-efficient engines, all running full throttle, 24 hours a day. The chips inside these data centers can get as hot as miniature suns, quickly overheating and failing if not actively cooled. Water is the most efficient and often the cheapest way to fight this inferno. It flows through pipes, absorbing heat from the chips. Then much of that heat-laden water is sent to cooling towers, where some evaporates as steam, carrying the heat away. It's a constant, furious cycle of consumption and evaporation. For these tech giants, water isn't just a utility, it's a strategic asset. Relying on municipal water supplies can be unpredictable, subject to local politics, droughts, and rising prices. So, an increasing number of these companies are taking a much more direct approach. They're not just buying land to build data centers, they're buying the water rights that come with it. Entire parcels of land, often in rural areas, are being acquired solely for the water beneath them or the access they provide to rivers and aquifers. This guarantees a stable, long-term supply for their ever-expanding operations, insulating them from future water scarcity or regulation. It's a classic move. Control the resource, control the future. Now, you might think, sure, they use some water, but how much can a few computers really need? And isn't it just recycled? But that's where the critical misconception lies. A single, large AI data center can consume anywhere from 3 to 5 million gallons of water every day. To put that in perspective, that's roughly the daily water usage of a town of 30 to 50,000 people. And much of it isn't returned. The water used for cooling eventually evaporates as steam, carrying the heat away. It's lost to the local water cycle, gone from the rivers and aquifers that once supplied communities, farms, and ecosystems. It's not just borrowed, it's consumed. The consequences are already rippling through communities globally. In water-stressed regions, where agriculture and daily life depend on finite resources, these acquisitions create intense pressure. Farmers, who have relied on local water sources for generations, find their access diminishing or their costs skyrocketing. Rural towns, already struggling, see their wells run dry as massive data centers tap into shared aquifers. Local ecosystems suffer as rivers shrink and habitats disappear. It's a silent, unseen competition for the most fundamental resource, quietly changing the landscape of local economies and natural environments. Your instant AI answer comes at a cost paid by someone else, somewhere else. So, the next time you marvel at the instant answers, the generated art, or the seamless efficiency of AI. Remember its invisible footprint. Every query, every line of generated text, has a physical connection to the land and water far from your screen. The AI revolution isn't just digital. It's profoundly physical, and its demands are reshaping our world in ways we're only just beginning to understand. The question isn't whether AI needs water, but what kind of world we are willing to let it create, and at whose expense, as its thirst only grows.